Good evening, everybody. We're going to get started. So if you'd like to have a seat, if you want to sit down, you don't have to, you can stand up. Wow, that got quiet quickly. Just remember that, Ramsey. I can command an audience. I know, I'm surprised. Well, I want to thank everybody for coming while other people are finding their seats. This is a real honor and exciting time to be here. When we originally thought we would do this, we thought we'd get 20 or 30 people. We just have an intimate group, and then Ramsey, who you'll meet in a minute if you don't know him already, came up with an idea to do this program, and so I'm excited that we have so many of you here. My name is Tom Erickson, and I'm the founding director of the School of Computer Data Information Science. And I'm not the oldest alum here. I'm going to recognize someone else, but I graduated in 1980 from. I'm actually, Ken Walk, you'll be happy about this. I graduated from ECE. I did not. Yeah. Are any of you not? First of all, not UW alums. Anybody raise your hands? So a couple, okay. Thank you. We're really pleased to have you here. No, we are. We're a very inclusive group, and how many of you are ECE like me, from there or from some? See, I'm not the only one. Yeah, awesome. Kang Wook, one of our panelists, is one of our ECE faculty, so I'm pretty excited about that. But I do want to quickly recognize a friend that I've known for many, many years. Tony is sitting in the third row back here, Tony Wasserman. Could you stand up so everybody could see you? And Tony is a 1970 PhD in systems from CS. So, great job. If you're not aware, Wisconsin was the second CS program in the country. And we graduated the first PhD, or the day we graduated our first PhD, there was another one at Purdue, I think. So two graduated the same day, and we're fighting about who actually got their degree first. But I also talked to one of our distinguished alums who lives in Austin, former CTO of Dell, an amazing individual. And he said, when I went from Caltech to Wisconsin, there were only two programs in the country, so it wasn't a big choice. And I'm very grateful that all of you chose to go to Wisconsin, whether you're a Wisconsin native or not. I grew up in Wisconsin. I was a third-generation Badger. It wasn't a big choice for me, but it was a big choice to come back in 2019 and start this school after 40 years of being an entrepreneur, mostly in Boston. So for those of you who are entrepreneurs, I can relate to you. And I can honestly tell you, we have a place for you back in Madison when you want to come back. There's a lot more opportunity. So welcome again. I'd also like to thank another very special individual, Jason Franklin. Can you stand up wherever you are? Right, thank you. So Jason and WVV is our sponsor for this. We would not be able to do this without Jason's help. So please, in the after party cocktails, please thank Jason also. So we're very grateful for that. We are a public university, and all of these gifts are greatly appreciated. So I have the honor of just telling you a little bit about what's going on. Our late former chancellor, Becky Blank, helped to create CDIS, this new school, which most of you are probably completely unfamiliar with. And this is a statement she made about the future of computing. And with a supporter like this, we've had an opportunity to invest a lot in our programs since you graduated, probably. We've added approximately 30 faculty in CDIS just in the last 3 years plus. That's a lot. We're now approaching 100 faculty for our school. And we did recognize that the biggest thing for us to move up in rankings and move up in programs and to support the programs is the need for us to hire more faculty. There's also a faculty candidate in the crowd, so all of you who are alums, I'm not going to introduce him. I don't want to embarrass him, but please encourage faculty and students you know to come. We'd love to have them in Madison. The vision for what we're doing at CDIS is actually kind of special. I like to think about it in this way, that we spent the last 50 years in computing building faster computers that generate more data, and then we build the hardware and the software, and it just iterates, and we follow Moore's law, and great things happen. But now that we're everywhere, it's very pervasive. I say we, the royal, those of us who are tech geeks like myself, that computing and data are pervasive. It's impacting society a lot, and it's really important that we start thinking about those impacts. And we're excited that one of our faculty members, Somesh Jha, earlier this week, co-hosted a workshop at Google that was well attended. Some of you attended that on really the existential future of AI. And these kinds of questions about how we're going to interface as society with technology is really important. And we see that, and that really is at the heart of what we're doing with CDIS at Wisconsin. And so if ask about our vision, it's trying to bring those things together. And you'll get a chance to hear a little bit more about what we're doing in CS in a moment. We have lots of opportunities to engage. We're here in the Valley. We've, since Ramsey Arpachi-Dussault and I started on our journey coming here about 4 years ago, we really tried to increase our community. We want to create a community. This is the largest community we have anywhere in the world, including Wisconsin, is right here. So it's important for us to be part of that, and we'll continue to be here and hopefully do more events like this to create this community and become part of it. And we'd like that community to also come back. And here's just a number of things that you can do. And I'm just going to say one thing on this. If you do nothing else, just tell people about your experience at Wisconsin. And that is enough, is just to say, hey, this is a great place. I had a great experience there. And, you know, let that be enough. But if you have an appetite for more, here's a list of some ideas. I must admit that I signed up for a lot when I came back. I didn't really quite realize what I was signing up for, but it has been really, really life-changing for me to be able to work with these people. So we'd love to see more of you. One of the things we're doing that's very exciting is that we're building a new home for all of us. CDIS is the coming together of 3 departments, computer science as being the largest of them, but also statistics, which is ranked very highly also, and our information school, which is, well, in fact, all of them are rated within the top 13 in the country. There's a copycat university just up the road a little bit here that introduced their new school and now college of, they call it CDSS, I think. They announced it 2 weeks after we did, so we beat them to it. That has a similar, it's somewhat aligned vision. So Berkeley, we're very proud to be in the company with Berkeley, and Cornell is the only other university in the country that has seen this opportunity to bring these groups together and really focus on what it means to have computing data and humanity really coming together. And this building will do that. We're very excited by this building. It's architected by a group designed by a group out of Seattle that did the UW building. So some of you may be familiar with those because some of you may be alums also of UW, I'm not sure. But we think this will be a really premier place, a home, and really, I call it a lighthouse for tech in the state of Wisconsin. And if you haven't been back to Madison recently, it has changed a lot. I keep hearing Christy Ebong here talk about how much it's changing. There are cranes everywhere. I heard someone else say earlier that Jeff Tangy, I think you're the one that said Epic is the epicenter of health tech in the country. And, 13,000 employees in Madison for that company and creating lots of startups. And so the dynamics are changing a lot. It's a fun place to be. And what we really needed was an academic partnership with that community. And this building, we believe, will provide that. We're very, very excited by it. Just in case you want to know where it's at, because this is all we tend to talk about, is it's really extremely located. We like to think it completes a tech corridor in the center of campus. If you know where CS was, since I think all of you do, it's actually literally right across the street from the current CS building towards University Avenue, next to the Discovery Building, kitty corner from the new Union South building. And so it's an amazing location. We expect to be able to have students from all over campus coming in there. We're building lots of little places and nooks and crannies. So when you come back and visit, and we hope you will, the building will be finished in 2025. There'll be plenty of places for you to hang out as well. If you need a place to work during the day and make some calls, whatever, just let us know. We'll arrange everything you need. We really welcome you back to campus. It is the home not only for CDIS, but with Ramsey's, and I'll bring Ramsey up in a moment. First thing he said to me was, you know, Tom, we need to have BMI in the building. I didn't even know what a BMI was at the time. Biostatistics and medical informatics. And, you know, through the grace and understanding of lots of wonderful people, we're going to have the group from BMI in this part of campus joining us, as well as the Data Science Institute, which is a new development in the last 4 years at the university. We're going to have the Center for High Throughput Computing there, and a new institute that I hope Ramsey will take 2 seconds and talk about, the N+1 Institute. With that, I'm actually going to go back and bring Ramsey up. So I want to thank you again all for coming. We do have drinks and drinks and appetizers again after, and I look forward to seeing you there. Thank you.
Hey, can you hear me? Yeah. Yeah, nice to meet you all. I'm certainly some familiar faces and some former. Thank you. I hope my woo is back at you and I recognize your face too. So anyway, I'm Ramsey Arpachi-Dussault. I call myself the outgoing department chair. So let's woo that. Woo. Not aw, woo. And definitely some people will be happy about that. In any case, I've had the privilege of being a professor at Wisconsin for 23 and a half years. It's the only job I've had, actually. So it's kind of embarrassing. And it's never really felt like a job. You know, it's one of those things where when you get to be around students like yourselves your whole career, it keeps you young because you look at the students and you think you must be close to their age. Of course, the shock that occurs is every day when I look in the mirror and I realize I don't look anything like a student anymore. It's quite depressing. So it's been my real privilege, and it's of course been my privilege to be the department chair for the last 4 years, actually 4 years minus 2 days. So you can figure from that when my term is ending, which is in 2 days. And in a moment, I'll introduce the next chair who we can all give our condolences to. So I mean support for, we could give our support to. So in any case, really glad that you're here. Lots of exciting stuff going on in the CS department right now. So many things to talk about, of course. Our undergraduate major continues to grow. It is still the largest major on campus. Yeah, it's over 2,300 students. It's hard to count them. They've gotten to numbers that are too big for our computer systems. So it's almost true, actually. You know, it's strangely, it's the biggest major, but it's also the second fastest growing major still on our campus. So we're fending them off, but actually what we're trying to do, and the reason we're fast growing and still large, is our approach has been, if a student comes to Wisconsin and wishes to study computer science and has, you know, the ability to do that, we are trying to enable them to do that. And for that reason, not only do we serve, you know, our Wisconsin students and our international students and our students from around the country and the world, really. So I know that there's interestingly, I've met so many students who are children of the Bay Area, right, where they've come to study with us. And the reason they know Wisconsin is so great is because of that thing that Tom encouraged you to do. You all talk about your experiences positively, I assume, and keep doing that because we have such a great reputation here because of you. They see that you have succeeded and you've told them what a great place it is. And so they all come to study with us, and what a great privilege that is for all of us. So like I said, biggest major, second fastest growing major. Of course, that immediately raises the question, what's the fastest growing major? and that's data science. So data science is the fastest growing major. It's already something like 1,200, 1,300 students, something like that. So that's in 3 years. That's jointly between the statistics department and CS. So we're doing some of the heavy lifting, statistics doing a bunch of the heavy lifting, and then our partners in the iSchool doing some work too. And of course, math and all some of the fundamentals are contributing to that major. And of course, we have a lot of really cool thing about Wisconsin, which I wouldn't say we designed, but it ended up happening because of the structure of our university. We have more double majors, I think, than probably any other similar top CS program in the country. Something like 40% of our CS majors are double majors in something else, probably even more of that in the data science space. So, and it's just this fascinating thing, right? A kid comes to study, let's say they're really interested in chemistry, and I've met many people like this. They do come and do a chemistry major, but then they also pick up like a CS or a data science major. And then they go off into their own fields that they were like most passionate in. Not everybody, like maybe most of us, are just most passionate about CS. And they're helping transform those fields. So I think there's some really cool stuff going on. And I think our education that we're providing is helping with that. So that's been fantastic, a lot of growth. We're of course offering a ton of new classes, classes in big data systems, classes in all the things that you can imagine are transforming the world, including some of the things that we're talking about tonight. And of course, as Tom also hinted at, he talked about 100 faculty across the three plus departments. In CS, we've just crested 50 for the first time, 50 faculty members. We're hoping to add one more. Where are you? So if you find him, work on him. But no, seriously, we spend most of our spring recruiting faculty, and like I said, we're the largest that we've ever been. One of the, we've always been really strong in systems, right? Systems areas like databases and computer architecture. We did some of the very early networking work. I work in, operating systems, distributed systems. But we've really been, of course, building up a ton in machine learning. I think we have across, not just in CS, by the way. CS has a really great core of people. We have optimization people like Steve Wright, whom you'll meet in a second. But we also have, of course, many people across the range of deep learning, machine learning, computer vision, robotics. And so we've hired a ton of new people in that space, but also in other departments. Our statistics departments hires machine learning people these days, fantastic people. There's people in the ECE department, which is in a different college, but we all work together because Wisconsin is a great place to work together. And in the biostatistics and medical informatics department, half of which is going to be in this building, as Tom mentioned, there's a bunch of AI researchers doing very cool stuff as connected to medicine, biology, et cetera. So lots of cool stuff, lots of great new people. Of course, we're constantly recruiting because it's a competitive world out there. So I guess a couple final things. Yeah, Tom did mention something which is more my personal thing that I'm working on, which is this new institute. I feel a little funny using a general platform to advertise things that I'm working on for myself. So I'm not going to spend too much time talking about it. Sorry, Tom, I know he hates that. But anyway, if you want to talk to me about this, it's kind of a new research venture, a new research, and really trying to build an institute that is going, we were originally interested in like Web3 technologies, but our idea there was, you can't call it the Web3 Institute because the day you do that, Web4 is going to be the thing. So like any computer scientist, we introduced a variable and we called it the N+1 Institute. So whatever today is, we're doing tomorrow's thing. So anyway, come talk to me about it. I'd be happy to talk to you about it. Anyway, so I think that's probably enough about the department. Thank you all for coming. I think what we're going to do now is have the panelists come up. So maybe the panelists can pop up here and we'll do some quick intros and then let's applaud for them. Yeah. All right. I don't know how you're sitting, so okay, you come all the way over.
You go first.
Oh, the slides. Okay. I think will I be here or is this perfect? Okay. I just do what I'm told. I have 2 days left this chair though, so I'm a little bit of a loose cannon. I'm in loose cannon mode. You can ask my faculty, like at the last few faculty meetings, I was sharing my opinions. This is what you don't do generally, but I was starting to do it. Anyway, first up we have Srinivas Narayanan. He's Vice President of Engineering at OpenAI, and certainly once he told me not that many weeks ago that you were moving into this position, I guess this panel idea was born. He didn't know that at the time, so my apologies to him. But honestly, thanks so much for coming. I was wondering if maybe you could just say a few words about your background and what you've been up to.
Yeah, great to be here. Pleasure. I graduated in Wisconsin in '97. I was in my PhD program, and I came to the Bay Area for a summer to Almaden. And after I finished my master's, I decided I never wanted to go back. So,
Oops.
yeah, talk about all the great things. Yes. No, I mean, I had a fantastic time, obviously. Fond memories of being in Wisconsin. I was in the database group. I was at IBM Alberton for a few years. I did 2 startups after that. I was at Meta for about 13 years. Did a lot of AI work towards the end of my career there, and at OpenAI more recently.
Yeah, thanks. Let's give them all a warm welcome. Thanks for coming. Yeah, next up we have Kang-Wook Lee, who's a professor in ECE, and maybe you could introduce yourself a little bit.
Hi, everyone. I'm happy to be here. I joined Madison ECE 4 years ago, CS affiliate as well. So I've been working a lot with CS students, CS faculty members. I mostly work on large language models and diffusion models these days. I feel like I'm happy to contribute to today's panel. So nice to meet you all.
Yeah, thanks for coming. Let's welcome him too. And really, we booed the ECE folks before, but all in good jest. I was actually, as an undergrad, a computer engineer, so I speak engineering. Yeah. Oh, yeah. So I understand that world a little bit. And, it's one of the great things about Wisconsin, actually. CS, ECE, and even BMI, all these departments, we all work together. We don't have some big boundary between us. Okay, last up, let's welcome Steve Wright. Steve Wright is a computer sciences professor and the incoming department chair. So let's congratulate him. Before Steve says a little about himself, he keeps pointing out that there's some sort of conservation of smiling going on between me and him. My smile has been increasing, and his smile has been decreasing over the last few days. So if I keep smiling, my apologies, and if he's frowning, it's just because of my smile. So
That's
my
right.
apologies. Anyway.
So great, thank you, Ramsey. Yeah, I was going to say I've been chair for -2 days, but that number is shrinking rapidly. I keep thinking it's a few months off into the future, but now I sort of realize the train is well and truly come down the tracks.
Right. So, and of course, what you're doing to start off is immediately he's going to Italy tomorrow.
Yeah. So I'm an imposter like the ECE people. I'm actually a math PhD from Australia in the 1980s. But I transitioned in the 1990s. I worked at Argonne National Lab in Chicago, and I worked in the math and computer science division. So that was my pretext for switching to computer science, which is something I certainly don't regret doing. So I arrived a little bit after Ramsey at the start of, the middle of 2001. So I'm 22 years now. And my research area is in optimization, but much of what I've done in the last 10 or 15 years has been related to machine learning because there's a lot of optimization in ML. So that's my background.
Yeah, welcome, Steve. Let's
Thanks.
clap again. So I guess, panel, do I have to sit now? Can I stand here?
Yeah, you
like
can
stand.
Yeah,
Why not? I'm the outgoing chair. I do what I want.
that's right.
So I'm going to stand here. That way I feel less like a panelist and more like the interviewer. Also, this works, and this is probably never going to work, this other mic. So we're just going to do some questions, some general questions to get the talent here talking, less me talking, more them. And then, of course, we'll have some time for Q&A. So, think of your questions as we go. And I guess what timing should I work on so that we get done and people aren't too angry? What do we? 20 after 7? Okay, so only not till 9 or something. Okay, and at some point, of course, people, and then we mingle afterwards.
Yep.
Okay, cool. All right, cool. So I thought we just.
Right on the slide.
Oh, very good. But it says 7:30. Okay. Panel till 20, then QA. Okay, I'm catching up with you. Thank you, Shannon. And thank you all, by the way. We have so many people helping us. I mean, how many people helped put this event together? We should do that before we get into the panel. We have Camille over here, Camille Robert, who works in the foundation, helped us out. We have Shannon Tim up here, who pulled this whole thing together. She directed the who else is on the team? Oh, Nick. Yeah, where's Nick? I can't see him. He's hiding. Oh, Nick Yeager, yeah, thank you. And then, of course, I mean, we should also thank the people working here. I'm sorry, I don't yet know your names, but thank you for working here this evening, and let's thank them for being part of it. Much appreciated. And okay, so we're just going to start out with something like basic, because I think there'll be people here who are literally like helping shape what LLMs are, large language models. We all know that these are on many people's minds because of what I'll call like one of the greatest demos ever, right? Suddenly they released a tool from OpenAI that everybody could use and marvel at, like how good it was is talking back to you or writing back to you, right? So I thought we'd just start with a simple thing, which I hope not to put you on the spot, but basically like, what are large language models, and why are people so excited about them? Can I ask you first that, Srinivas?
Sure, yeah.
Yeah.
A large language model is a system, AI system that is trained on a lot of text. And the core primitive is to train a model that tries to predict the next word based on all the context that it has before. And the amazing thing about it is that's sort of the first step. It builds a model of what it sees, and we then use it to align to what we want the model to do. So there's a second step after you train the first step, which is to say that we have some techniques called, just doing some supervised fine-tuning, using some human feedback to align the model, which broadly says, once you have the underlying model, how can you get it to do useful things that people want it to do, right? So think of it as a second step. And at the end of it now comes a system that you can start talking to and have conversations with. And the amazing thing about it actually works pretty well, right? So you can ask things about the world, it can ask new questions, and the surprising thing that we found out a few years ago is that they tend to be pretty good at answering things that I've sort of never seen before, right? You call it zero-shot learning or few-shot learning. You give it a few examples of what you want it to do, and it's able to generalize. So the ability to generalize, I think, is one of the most amazing things that we have seen from these models. And the ability to have conversation with people, I think it's been very surprising to see how well effective it's working.
Yeah, no, I think that's great. By the way, how many people use them, let's call it occasionally, use and then, great, most of you. And then how many use every day, like I'm using this thing for my work or for fun? Yeah, a bunch of you, right? So it's kind of fascinating, obviously a group that's already being transformed. I guess we're making you happy by showing that answer. So fantastic. So we're going to talk about a few different things, and thanks for that overview. We're going to talk a little bit about research. We'll talk about what interesting things people are already doing and then where they might be going. And we'll talk about education, right? We'll talk about that. We'll talk about industry. I think one thing we'll talk about also is industry and academics and how these two will interact in these spaces. I think the world's a lot different than it used to be, where with so much investment in industry. So I think there's a big question around how do academics coexist in this world and help still innovate and push things forward, even when there's these multi-billion or trillion-dollar investments in all of this world of industry. And well, I think we'll then kind of get towards the end, we'll be a little bit more speculative and talk a little bit about the impact on workforce and society of some of these tools, which will be more speculative. I don't know how, to the limit that people want to guess. And then, maybe kind of where is this going? Like is this the beginning of something towards really artificial general intelligence, which people have been talking about for a long time? So I wanted to start on the research side, and maybe here I'll start with Steve. Maybe I'll let you start with this, or do you want to? Is that okay?
Sure. Yeah.
Yeah.
So my knowledge of this is much less than my two colleagues here, but my general take in anything like this, large complex systems, is to try to distill them down to their essence and to try to understand at some theoretical level what's going on. That's one thing I like to do. And there is work of that flavor going on in the large language model space. For example, people are taking in-context learning on the very basic machine learning problem of linear regression, which is a problem that dates back about 250 years to Gauss and so on. And they're trying to understand what happens when you try to get a large language model to do linear regression. And what they've shown is that it's behaving. They take a very simplified model, which you often have to do. You can't take a large language model in its full complexity with all the engineering tricks that have been introduced to make it work well. You sort of strip it down to a very basic simplified version. And you ask yourself, or you try to understand mathematically, what is it doing with this very basic problem? And there have been some very recent papers just in the last few days where people have come up with, very interesting explanations of how it's behaving. Now, the challenge is to go from that very fundamental level and ask the question, does that really tell us something interesting about what's going on in the full-blown model, or is it sort of too simplified to be useful? But these are all the steps we have to take in research, and that's the kind of research I like to do. The other kind of research has to do with the algorithms that are used to train these things, because as you know, training of these models is extremely computationally intensive. So this throws the spotlight back on algorithms, and how can we squeeze some more juice out of these optimization algorithms in particular, which is something that my research has been about. How do we squeeze juice out of them? Because now it has real economic importance if you can get a significant improvement in the algorithm. So there's just some issues. Of course, there are many others that my colleagues would know about.
Yeah, thanks for that. A great intro. And Kang-wook, I don't know if you want to talk a little bit about kind of things you're thinking about in this space. I know you're an active researcher and, still, I think not tenured yet, right? So you're going to be, and not that this has to do with his tenure decision, by the way. So,
Thanks
well on his way to tenure. So
Thanks for the reminder.
yeah, no pressure.
So yeah, I have started working on language models, the research side, about 2 years ago now. I think the first impression I had was basically the GPT-3 paper that got the best paper award from NeurIPS 2 or 3 years ago. And I was so jealous because I was reading the paper, and the paper was basically saying that, hey, if you have any NLP task, like language processing task, you don't need to train a specific model for your own data set, because you can just use this few-shot or in-context learning with this GPT model. Then boom, I was so jealous because I was always spending research money on training my own particular models for solving different tasks, but NLP people can just use this pre-trained model for their own purposes. I was so excited to see that phenomenon. Then I was thinking about, okay, wait, can we do it beyond NLP task? That was my first research question. And I went home, and after seeing that paper, I went home and started running some experiments on my own with GPT API, put my credit card and try some experiments. And what I did was this. I don't know whether any of you remembers this iris data set from the old statistics or machine learning course. We always use this iris classification data set. So what I did was this simple experiment. So I just took the training data set of the iris data set. It's like the first row is, hey, this is item 1. The sepal length is this centimeter. Sepal width is this, blah, blah, blah. And then this flower is iris, whatever, setosa or something. So what I did was, okay, I just manually converted everything into sentence. So this is a flower of sepal length 3 centimeter, blah, 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 boom. And then I just gave a few examples. From the training data set, I took some rows, converted it into sentences, put it into the context, and then I just took one row from the test data set and asked the question, like, oh, there's a new flower, sepal length is this centimeter, blah, blah, blah. What is this flower? And it got it correct. Okay, so, well, that's interesting. So I tried something similar for even for MNIST image classification data set. And after some fine-tuning a little bit, it started working. It's like, okay, wow, this is crazy. So I started writing a paper on that. That was my first paper on GPT. And then since then, I've been super excited about many different aspects of language models. I've been writing a few papers on that. But then the main research question I have these days is there's a huge difference between what we used to do with machine learning models before and these days. Before, we had a model that is trained, and at test time, we just use it as it is, because we had image and give it to the number, and there's no way you can further process it. But these days, we have this fairly general input-output format, which is called language. So you take the input as input, take language as input, it outputs language, another sentence. But then you can maybe feed it back again, or you can connect it to some other model. So this kind of modularity of multiple models and designing a bigger system out of pre-trained models, I feel like probably we don't need to train any more models because we have really good image models there, really good language models out there. And maybe simply by composing these models in a creative and new way, maybe we can create many more interesting systems out of it. So that's kind of a real interesting question, a research question I've been working on these days. So I'm happy to talk more later.
Yeah, how cool is that? Thanks for that. That's really well said, and kind of captures, I think, what's going on right now, right? People are like exposed to this really powerful tool, and then suddenly realize they can do all this cool stuff that right at your fingertips, and it's so accessible. So I'm kind of continuing that research line of thought. I don't know, Srinivas, if you, obviously you can't say, here's all the things we're doing research on. I mean, or maybe you could, I don't know. But I'm curious, like how you view the research and new things you're doing internally versus like what's going on in the community. How do you pay attention to all that stuff versus the things you're thinking about inside? And then I think what I'd like to lead towards is a little bit of a discussion around, what do you think the ideal interaction is between academics who, want to advance the state of the art, want to do cool stuff, and then these big companies. I mean, even you're a pretty small company, but growing, of course. All this corporate interest and huge amount of dollars and things, and like how that world is going to evolve over the next so many years.
Yeah. So multiple questions there. I think on the research side, yeah, it is hard to keep up. I kind of try to do my best staying abreast of whatever is happening, but some of the themes that we work on are like, it's sort of obvious in some ways, right? Which is, here's a model that learns to operate on text, it learns to predict things, it's sort of useful, but it's still not great, right? Like it makes a lot of mistakes, it hallucinates, obviously. And so we have very clear problems to solve there, reducing hallucinations, making it more useful for people. And if you start thinking about, okay, how can we make this more useful for people? Intelligence is not just text, right? It's about like processing all sorts of things that we encounter in a real world, right? Like what we see, etc. It has, we have some early work on like getting the models to learn to use tools, for example. How do you do that, right? So I think we're sort of, our ultimate mission at the company is to just really solve intelligence and build generalized intelligence and make it useful for all of humanity. So there's also lots of interesting research questions on how is this going to impact people? How do we keep this safe? How do we get them to do what we want and not go off the rails, right? So there's lots of sort of maybe more practical considerations that are also important research problems.
Oh, yeah, great.
Yeah.
I don't know, Steve, do you have any further thoughts on that? Have you thought about like, have you in your interactions, like, you're the more kind of industrial side versus kind of the more theoretical stuff that's a little bit maybe removed from industry.
Right.
How do you see yourself?
Well, it's coming into the workflow for academics in all areas in many different ways. For example, just the way we write papers, we use this language called LaTeX, or most of us use LaTeX. And ChatGPT is helping with that. Like we have to make bibliographies, we have to store papers in bibliographies. If you upload some, terrible formatted bibliography with all kinds of mistakes into ChatGPT, it'll just fix it. It'll just spit out, perfect BibTeX code. And that's something, it sounds trivial, but I mean, it helps me a lot. It saves me a lot of time. Yeah. Another thing that I've noticed, and again, just a sort of anecdotal thing, is that my students often write me messages in the middle of the night complaining about the homework and, if something's going wrong with their code and whatever. And these messages used to be kind of rants and somewhat not very articulate. And now they come beautifully composed in beautiful paragraphs with, flowery language and starting out with "Dear esteemed professor" and all this sort of thing. So I just noticed that happen literally overnight. There was a change in that. So there are a couple of, just day-to-day things that are different that change my workflow.
That's hilarious. Yeah, I did, like I said, we do a lot of faculty recruiting, and I'm pretty sure that for the first time this year, I got turned down by not the faculty member, but by ChatGPT, as prompted by the faculty member who went to another university. So it was very interesting to see this mail, which is clearly generated, like no human being writes that way. So in any case, it is kind of funny. So I was wondering if we could transition a little bit to, education. I mean, of course, we could talk about research forever. It's clearly going to have a big impact on education. And I don't know who wants to go first. I don't know, Kangwook, if you've thought about like how this is going to affect classes that you teach and how you might change how you do homework assignments or projects or anything like that.
Yeah. Well, I guess my current mindset is more like they are going to use it anyway. There's no way we can let them not use it. And I guess I don't think anything bad in using it in every aspect of their workflow and every step of their learning process. I'm more on the pro side. I'm all for suggesting them to use it. I guess the tricky question for teachers like us is how should we reformulate the way we teach so that it's more robust to people who are going to misuse those technologies, like doing homework using ChatGPT from scratch. I'm happy to see people using ChatGPT to answer their questions, maybe to improve their code and see their and find their mistakes. That will lessen the burden on our TA side. Maybe that's good for us, but yeah, just doing homework from scratch, asking ChatGPT to answer all these homework questions, that's not good. So the problem is how should we find the right balance between the misuse and the good use? I think that's our challenge. We could have asked the same question to ChatGPT, and they probably came up with better solutions that I haven't thought about. Yeah, but we'll see. But then also at the same time, for me, it's really great tool because I'm developing a new course, and developing a new course is really time-consuming process. But right now with ChatGPT, I can actually make it much faster. So that way, there's also a pro on our side. Well, yeah. But yeah, it's actually super easy to write a new syllabus from scratch. Took 20 minutes. New lecture notes, like a few hours. So I think it's also really good for us to also adapt our curriculum at a much faster pace than before. I guess right now, changing and updating the curriculum is taking forever. So it's kind of like slower, like scaled version of what's out there. But I think with that tool, we can also improve at a much faster pace. So that really also changed the way we teach.
Yeah, thanks. By the way, while you were doing that, I did ask ChatGPT if it should be used in education, and it said unequivocally yes. So AI systems have a significant potential to be used in education and can contribute in a number of ways, and it gave me a long list. So I don't know if you trained it for that, but
I think that's going to be a better answer than what I'm going to say. I think.
Yeah.
No, I think for me, like there are three key elements that are going to be amazing for how AI is going to impact education. First is the ability to personalize and really meet the person who's learning and where they are, right? And I think that's a very hard thing to scale, and the ability for us to personalize that is going to be amazing. Two, it's going to be interactive, like just back and forth. And I think those systems are going to be amazing. And the third, I think we don't talk about as much, is also the ability to access anywhere in the world, lots of low resource areas. And I do some work with a nonprofit where which really tries to create educational content and for underprivileged kids in India. And you have visited some of these places, and it's like amazing to see these kids they really don't have internet, they don't have devices. The number of teachers that are available are so small, but I think this is going to be very transformative to be able to take education to everywhere in the world, right? And I think that's super powerful. And I'm also really glad to hear that, which is, it's not just about helping the students, but we can also help the teachers teach better.
Yeah, I think there could be a real democratization. It's fantastic. Steve, I don't know if you have thoughts on the educational side as well.
No, but it was actually Kang Wook that showed me that he gave a talk in Chicago a few months ago, and he started writing at 11 o'clock the night before. And the last slide in the deck of this beautiful 20-slide deck was announced that it had been written by ChatGPT. And he explained the process to me, and it was, obviously there was some human intervention there, but it was, very impressive. So I think that's a very fair point, that obviously it's going to change the way that we pose the sorts of questions we ask students. It's obviously going to change that, but a lot of what we do is not going to, I think, yet be addressable, famous last words, but it's not going to be addressable yet with ChatGPT. And I think we still have to tell people how things work, even though they've now got this shortcut available to them to get them to the final point much more quickly. But that's happened very often before in technology. It used to be people had to use slide rules or do multiplications or long divisions on pen and paper, and now calculators came along. And we still told people how to do these things, but we didn't expect them to sit down and do them the old-fashioned way anymore. And there might be some analog with, what ChatGPT brings to the table.
Yeah, thanks for that. So,
can I make a short plug?
Yeah, of course.
Actually, a few of us are trying to AI for education, aimed at low resource areas.
Yeah.
So if any of you are interested, ping me. It's going to be sometime in, I think, late August, mid-late August.
Oh, that sounds fantastic. And they should just directly mail you
Yeah.
Okay, cool. I'll definitely mail you about it. That sounds fantastic. I hope to get a bunch of students working on that. Okay, so we have certainly a few more minutes. I'm wondering if we could talk a little bit more broadly about, potential impacts on, workforce and society. I know a lot of the concerns in this space, as well as the opportunities, are, which you pointed out, like in the educational space, relate to, hey, how is this going to transform what's going on, both in the near term and long term? How is this going to change the shape of everything? I mean, I think your educational example, Srinivas, is a really interesting one because, you talk about the opportunity, right? A personalized education, especially sometimes for people who may not have access to a really great teacher. But eventually, like, is that your teacher, right? Or is there a role for the teacher who isn't the chatbot that you're talking to? So I'd be curious if you all have thoughts. I don't know who wants to go first. Of course, anybody happy to speak about, where are the impacts going to be, both positive and, and then thinking about how to prevent negative ones from happening as we go forward. I don't know, that's a tough question. So yeah.
I can take a shot at it.
Yeah, sure.
I think there will be economic impact, and I think very significant. Just like with major technological changes, there is always, impact on jobs, and there will be impact here as well. I think we are generally not great at predicting what the future jobs are. So I will refrain from predicting what exactly they are going to be. I am a firm optimist in that, like, just with every previous technological wave, we have figured out what the new jobs are, and I think this will be similar. I think humans always want to see humans do other things, and we will figure out what those are. In the short term, I think it's going to be more assistive in many cases, right? Today it's doing tasks, not entire jobs. And so I think it'll be a huge productivity improvement for people in the next, few years, right? And I think that'll be great. It's unclear to me if exactly when it'll become to a point where it can entirely replace somebody. And I think that will happen at some point, at least in some jobs. But then those jobs, I think, will find newer jobs for these people to do. Just to give you analogies, like technology automating what people used to do is not new, right? It's been happening for centuries. AI is better at playing chess than any human in the world. We still watch people play chess, right? AI is faster, machines are faster at moving from place A to place B. We still watch humans race, right? So I think there is like an inherent desire in us to just want to watch humans do other things. And I think with that fundamentally being true, I think there will always be new jobs where humans are at the center of this, right? It's just very hard to predict what that is going to be, 10, 15 years from now.
Yeah, thanks for that. Kang-wook, I don't know if you have some thoughts on this topic.
Yeah, I'm more like imagining a kind of like very scary scenario where people upload their memory and whatever they said to the database and have some like fake of you who could be accessed even after you die. So that's kind of like the scenario I'm like trying to imagine, and maybe should I start recording whatever I say right now, just in case I just get into an accident and I get I'm missed by someone else. I mean, there could be something bad about this kind of scenario as well, but also there could be some positive things. Like you can talk with some, I guess some people have already implemented an app where you can talk with, let's say, Albert Einstein. They just put their whatever bibliography and make that agent to speak like Albert Einstein. Then they speak like that. There's another like Jesus app, there's a Buddha app. And it's like there are so many people who are trying to like make an agent that speaks or write like people who are not alive right now.
Yeah.
And it's already pretty good, but that's also kind of like based on limited data. But if you actually take the entire like conversations you or whatever saying you throughout your life, and I think it's probably going to be closer to real living person. So how can we, what people will do with that, we can prevent that happening. So that's my, how can we distinguish from alive, person alive and who's actually not alive?
Yeah, no, interesting. I mean, the one like a positive view of that same thing. I know at least one instructor was recording all their things that they said in class, doing some training over that, and then using it as like a first auto answer on Piazza to a student question. It's basically whatever, ChatGPT knows plus whatever the instructor said. And that already was kind of like, a good first answer to things, which is kind of like what you're saying, but maybe it doesn't sound quite as ominous. So Steve, I don't know if you have a
Yeah,
thought on
well,
this.
I think these questions about societal implications and human things bring in a lot of, expertise from outside of CS. And I think this is where our CDIS context is really going to help, because the information school is all about, the human element of these things. And I think being in the same college, school at the moment, maybe college in the future, with people whose, day-to-day business is that, and being able to collaborate with them on these questions is going to be really important.
That's a great point. So I think
Maybe I'll add one more, right?
Yeah,
Like it's just in the history of our civilization, improvements to human productivity has always been one of the consistent factors in economic growth, right? And there's very few technologies that apply at such a scale to every industry that I have seen. So the optimist in me believes that this is going to be one of the biggest drivers of economic growth for a long time.
Okay, great. That's I think a great note to end the panel. Let's before we do a QA, let's thank the panel real quick. So think of your questions. Before we do a question, I think we're going to have a quick announcement from Lang. Lang, come on up here. Lang is one of our fabulous alums and also helps coordinate a lot of cool stuff in the Bay Area. So.
Thank you, Ramsey, and fascinating topic. I just want to let everyone know there's actually a Bay Area CS Alumni Club. How many people know about that? Yay, okay, not enough. So we actually have an annual picnic kind of to continue the CS department tradition. And this year's annual picnic is going to be on September 30th. It's in Sunnyvale, the Enza Park. If you receive an email about this event, then you will get that notification too. But if you don't, make sure that your email is with Camellia or with Shannon so that you'll receive that event. It's well attended. We usually have 50, 60, 70 alumni from really old alumni, mature alumni.
Really, really old.
Yeah. To summer interns, so it's a really good event just to have fun. So, and besides the annual picnic, we also have mentor events and things like that. So get connected, just to kind of, badgers in the California. So watch out for that, and really make sure that your email is, with Shannon and Camellia to kind of get that information. September 30th in the afternoon. Mark your calendar.
Great.
Thank you.
Thanks. Yeah. All right. So how are we going to do questions? Oh, if you can I just run around, or do you want people to walk up? Okay. So people line up to. People want to ask a question. Pop up here. Ask a question. Otherwise, I'll call on you. I'll wait for a question. All right. Go ahead. Hey, good to see you.
Hi. Such a wonderful event. Thank you. And I'm Dhaval. I'm a 1996 MS Computer Science. Srinivas, we used to be together.
It's a good year, apparently.
Thank you. So the question I had was the multi-pronged. One is, how does OpenAI hallucinate, and other LLMs too, not only you, but why does it happen? And the other question I had is that we heard of these services like Khan Academy has a companion, OpenAI companion, Checkmate. Chegg has now a thing called Checkmate. How does that, can you elaborate on that?
I don't know the Checkmate part. I think Khan Academy has used, our LLMs to sort of build a product which is really about education and helping people learn things better, talking about some of the AI for education stuff that we talked about. And I think I've seen some demos and they're awesome, right? Why do they hallucinate? At the fundamental level, it's like a probabilistic model that is trying to predict what is the next most likely occurrence based on everything at FC, right? And in the process of doing it, it has sort of built some internal model of whatever it has seen, and it's trying to make a probabilistic guess about what is right. There is no way to verify what it outputs, right? So there is no objective truth. And so that is, one of the reasons that, it produces things that may or may not be factually correct, and there is no way to verify that. I think there are lots of techniques people are working on to reduce that and eliminate that, but I think we will make progress on it.
Yeah, thanks for that. And let's pop over here, and maybe make sure also just to introduce yourself and then ask the question.
Great. I'm Jeff. 93, work in health tech. So the question about hallucination, I think, relates to healthcare a lot. And your comment about chess, I thought was really good. You know, people saw IBM do Deep Blue and win at chess and win at Jeopardy, but then it didn't do much more, right? So the investor skepticism is that maybe ChatGPT is just really witty and fun to talk to, but won't be able to do much more. So I'm curious about your thoughts on the opportunities of, I don't know, retrieval augmented generative models or other models of making it more accurate, because for healthcare at least, there seems to be a lot of concerns, but a huge opportunity.
Yeah. Couple of things. One, I mean, ChatGPT is fundamentally different from Deep Blue and other systems we have built before, right? Those were built as highly specialized one tasks, go and optimize that, right? They were not general. And this is fundamentally different. These systems are way more general than what we have ever built before. And I think that should give us all a lot more optimism about how broadly applicable these systems are going to be. So that's one. I think the answer on reducing hallucination, I mean, the honest answer is it is an open research problem. Like, I don't think we know how to do it yet. I think we have techniques that will curtail it to a large extent. And the question is, I think there will also be a series of use cases where you can tolerate certain amount of error, right? And today you are seeing this being used in areas where, yeah, you can tolerate some amount of error. I think that curve will keep improving over time. And so new tasks where the error tolerance is lower will start to, these models will start to be more useful for that. It's unclear that the current sort of architecture will completely eliminate it. But at the same time, there are also novel things people are working on. So, you know, it is a research problem, and I'm optimistic we'll find some ways to solve that. Yeah.
I know the students, for example, tolerate a number of errors I make in class. So an imperfect educator, at least, I think can be useful. Maybe not. Okay, let's pop over here.
Hello, my name is Roger Midmore, CS 2001. You know, my question relates to about 15 years ago, neural networks came on the scene in linguistics and pretty much blew away everybody's statistical NLP models that we use. You know, for people outside, you know, the only thing we know about these models is that the complexity score keeps getting lower and lower with each iteration of the models themselves. For people outside the field, you know, statistical NLP doesn't use Claude Shannon's information or bits per word for encoding. They call information complexity and just give a raw score. So about 2014, I think recurrent neural networks were given a score of 80 for the Penn Tree Bank. Your ChatGPT with your zero-shot learning from the Penn Tree Bank in 2020 gave a score of 20.5, and you know, your company was claimed we have a score of state-of-the-art. However, that's actually incorrect. The state-of-the-art in the field has been the quantum theory of information, where the you know, the concept of entropy is actually replaced by that of black body. You know, the upper range is probably around what ChatGPT was getting. And the lower range is probably around 13 for complexity on the Penn Tree Bank.
So can you turn it into a question so he can answer?
I was wondering, you know, do these models, what are the relations between Bose-Einstein statistics and more generally electromagnetic radiation and back propagation in the models you guys use?
Sounds like an easy question. Steve. I don't know how to answer that question. It sounded very interesting. Kang Wook, you're ECE. It sounded closer to ECE. Am I right? It sounded closer to ECE.
Sure.
You know, great question. I think we're going to have to take that one offline because it sounds like we're going to have to unpack it a bit. So let's pop over here and then we'll come back to that offline if you want to pop up afterwards.
Okay. Hey, I'm Jordan. I graduated in 2012. So my question is more or less aimed at Srinivas, but I'm happy to hear any answers. But so regarding safety, and when we're talking about the possibility of producing an artificial general intelligence, at least in the span of time that we're thinking about planning, what do you think about strategies for combating the possibility of catastrophic downsides, like extinction risk that people have been talking about? Do you have clear strategies for the most interesting techniques that you're thinking about? Are you starting to see the limits of reinforcement learning from human feedback? And what new techniques are you most excited about?
So the question really is more around AI and extinction risk. Is that sort of what I'm hearing, or is it broadly safety in general?
I mean, I'm interested broadly in safety, but
Yeah.
Extinction risk is certainly a topic on my mind.
Yeah. I mean, look, I think it's a very broad topic, and the safety element spans multiple dimensions, from how do we prevent this from having misinformation and hate speech sort of stuff, creating fake videos, that sort of stuff, like sort of more near-term misuse type of safety. There is safety, which is a little bit more subtle, which is as people start to use these models, are they going to completely believe what they're doing, even if they're wrong? And there's a sort of a human persuasion element to it. And that's different, I think, as a new interaction paradigm. So how do we think about that, right? I think that's important. There's safety from like an economic impact perspective. How do we think about that, right? There's then sort of really longer term safety, like you're talking about, what's going to happen if these things get out of control. So it's a pretty deep and broad topic, and it's very actively being worked on and actively being researched. I don't think I can give you like one magic answer that is going to solve all these problems. So we are taking these pretty seriously. I think that is one of the things that I'm really, I care about a lot. And one of the reasons I joined, as well, is that, this is deeply in the DNA of the company, and we want to steer this in a way that is positive for everybody. And we want to kind of prevent all the negative consequences. So it is in everything that we do. Like, I think we have talked about this publicly. GPT-4 was tested for like many, many, many months, 6 to 8 months, before we launched it out. And we're going to be very careful before we put them out there. But like, I don't have all the answers to your questions. I think we'll have to work on it.
Yeah, and great question. I think a lot of people are thinking about it. The glib side of me wants to say something I heard earlier, which was like, we were able to suddenly predict the next word kind of okay, and everyone's like, we're all gonna die. Like, it's kind of like, maybe it's a step or two away, but less glib, I would say. There's a lot of societal systems, right? Like capitalism. Is capitalism safe for everyone, right? Or does capitalism drive humanity in ways that we don't want? We have to ask those questions about everything that we invent, not just this particular brand of AI technology. And I think Steve said it very nicely earlier. One of the reasons we formed this school was so that we don't just develop technology in a vacuum, that we're connected more to the humanities, to the impact on humans. We've been certainly hiring more people that do things at the human-computer interaction interface. That's been a growth in CS in the iSchool. And so I think those are questions universities are actually well poised to address. And increasingly, I've been trying to make some connections between ourselves and people in public policy. And I think there's just so much opportunity to not just think about the technology, but think through what it means to help people who are shaping public policy, help us build guardrails and all the things we need to make society run well. So I think really good question, and something we'll all be working on one way or another. I think all of us as technologists, we owe it to ourselves, to our world, to think about these questions. So thanks for that. So let's do like maybe just the people who are standing. So let's try to do it quickly. Okay, you go next.
My name is Ifan, and I'm a live example about double major. So I double major in both computer science and statistics.
Oh, fantastic.
Yeah. And my question is, I try to use OpenAI API, but it's super expensive because it's charging per token. I know that some universities like Berkeley or Stanford has already done this trail model to help to reduce the model size. Is UW-Madison gonna do something similar? Or is OpenAI gonna support some education version for students to explore more?
So Steve, that's part of your first job as chair, is to find some discounts for these people who are trying to use the technology, for God's sake. And of course, the person you should ask is right here.
Right. Exactly.
We do have a variety of models. Some of them are free, right? And yeah, so you can try some of the I think GPT 3.5, there's a free version of it. I think we charge for GPT 4. We are working on lots of optimization, so I do expect the cost to come down over time for sure. We definitely want this to serve as many people as possible, as broadly as possible. So I think, the lower quality models, there's going to be definitely more free stuff. And the higher ones do cost us to run, so we'll have to run it in a sustainable way, but our goal is to actually try to make it as cheap and efficient as possible and serve as many people as possible.
Great, thanks for that. We'll work on it. Okay, quickly over here, and then one last one over here. Yeah.
Thank you for the wonderful event. Jian Bo from class 2016. Question to the panel. Imagine right now you are not a university professor, you are not a technology leader, you are right now an elementary school teacher. How would you actually design your elementary school education agenda program to prepare the young kids for a future of generative AI? Thank you.
I mean, we're barely able to figure out how to teach college students. Now we have to. Now we got to figure out elementary school too. Okay, Steve, go.
No, okay. This one, I think I'm stumped by this one. This is no. I think I'm going to pass.
Pass. Pass one. Okay, who's next? Who's going to tell elementary school teacher? I mean, that is a hard job, right? Like 5-year-olds. I mean, it's a fantastic question, right? It's a question is like, you know, given that you're there must be somebody in the room that probably has like a 5-year-old, right? Or some young kid, right? So the question is, what should they be learning in this world where this is there from when they're 5, right? Like, you know, they just learn how to talk, right? They shouldn't use it. Yeah. Okay, well, I appreciate that. That's one approach. I think maybe another way to look at it is where does technology get introduced to children at what ages, right? This happens already with phones, and we've seen the good and bad of that, right? I heard about one thing where there was one particular private school where all the parents agreed not to buy their kids phones until, like, I forget, age 14 or something, so they could prevent the influx of social media and so forth. That said, I think here there's some real opportunity, right, to help with a bunch of things, help with learning. And so I think it's a great thing for us to engage in. I don't think we have the answers, and hopefully we get to work on them.
Yeah, I think at the elementary school level and stuff, there's lots of basics. But I mean, zooming back, I think the most important skill for anybody to have is to learn how to learn. And we have to figure out how to teach people to do that, and also how to be adaptable, I think. All these are building blocks towards that, I think.
Yeah, and if I could just jump in there, like the one thing I understand your point, like, hey, make sure you learn the fundamentals, right? Reading, writing, arithmetic, all that stuff. But the thing I think we have to think about is, a long time ago, I've said this a lot, but maybe if you've seen a talk from me before, you've heard me say it, but I read this New York Times article, and it said, it's not that, this is kind of like the chess thing. It's not that AI is going to replace, it was about chemistry. It's not that AI was going to replace chemists. It's chemists who use AI are going to replace chemists that don't use it. And so I think the thing we have to be careful of is if we aren't training our kids to use the tools that are out there, well, somebody is. And then they're going to be left behind, right? Because those kids are going to work faster, better, smarter than the ones that don't. So I think that's the thing. We can't just close our eyes to it. We should embrace it. I think that's what Kang Wook was saying earlier, and then see how to do it in a safe and positive way so they learn better, more, and can do things better. Anyway, one last question.
Okay. Yeah, my name is Jian Jun. I got my PhD from database area in Wisconsin end of 2001. Ramsey was on my defense committee. He was just moved to Madison at that time.
I know, and then when they ask you to be on the committee at first, you have to vote yes, because you don't know what's going on. I mean, like, you're there, they're like, this is my student. I'm like, okay, looks pretty good.
Okay, yeah. So
it was good, by the way, sorry.
Yeah, so my question is, I think that the ChatGPT or LLM is a kind of like a revolutionary kind of thing. But for a lot of like us, like doing like a system work, so I really want to know like what are the new big challenges for the system people, right? Last week I was at a Sigma conference. I talked to people, like database people, say, hey, what the database people should do? Like, what is the big thing, like for the large like model ChatGPT? I feel people don't have much clue. I feel this is a general thing, right? What is the opportunity for the system folks? What do we need to, or what we can contribute in this revolution?
Yeah, great. All right, Srinivas, maybe you go first.
I mean, these are huge systems problems, right? So if you just look at the amount of compute that goes into training any one model, it's kind of like, it's a lot. And it's only growing exponentially. So that creates all sorts of systems problems, right? And right from how do you optimize compute, communication, et cetera, going back to one of the earlier questions we talked about, like how do we make these models faster and cheaper so we can serve more people? That's absolutely a systems problem. Right? So there's plenty of opportunity here for systems people.
Yeah, and I think, great question. Personally, I think there's the systems that are, doing the training, there's the systems that are doing the inference, and that's all very, I think, classical systems kind of work, optimization. I also think that people are going to be building new kinds of systems, right, that incorporate these things. I just saw the other day, there's like this paper by these chemists that like kind of pulls together all this crazy stuff. Like it's reading chemistry papers and it's generating ideas from it. And it's kind of a different kind of system. So I think there kind of might be some really green space and just thinking about what kind of systems can we build now that we have these kinds of technologies like ChatGPT. So anyway, we're running over and people might be wishing to mingle and so forth. Let's thank our panel one more time. Thank you. Great job. So as you can see, and all of you, of course, the absolute best part about our jobs, the jobs of people working at the university, is that we get to interact with students from the past, students who are current, and of course even the students who are coming here in the future. So thank you all. It's great to see you. We'll be around for a while, and thanks again to the panel.
Hey, thanks, Ken. Thanks for coming, man.
Oh, are we going to do? Okay, photo. Okay.